What's up, guys? It's me, Sir Ernest, and today we're going to solve problem 9.3 of Thornton and Marion 5th edition. The problem reads, find the center mass of a uniformly solid cone of base diameter 2a and a height of h and a solid hemisphere of radius a, where the two bases are touching. We already calculated before the center mass of the solid cone and the solid hemisphere in our previous examples. And we found out that the center mass for a solid cone is h over 4. So it's somewhere here. On the other hand, for your solid hemisphere, the center mass would be 3 over 8a. But because the solid hemisphere is oriented this way, this will be negative. And that location will be somewhere here. Now, by definition, these positions represent the center masses of the two objects if they are separate from each other. But here they are combined to each other, and we can reduce this problem into a two-particle system wherein the masses will now be located at these points. So let's call this the mass that represents the mass of the cone, MC, and this would be the mass of your solid hemisphere. So let's call it MS. So this is now reduced to a two-particle system, and for this kind of system, the center mass can now be rewritten as ZCM equals 1 over the sum of the masses MC plus MS times the sum of the products of the masses and their corresponding center masses. So we write this as follows. MC times ZCMC plus MS ZCMS. So we already know the center masses. So all we need to know would be the masses themselves. And we can calculate it from the fact that we have a uniform object wherein rho, which is your mass density, is constant and they are the same. So the mass of your solid cone, MC, will be equal to rho times the volume of the cone. And we already know from your geometry that the volume of your cone is 1/3 pi times the square of the radius times the height. Meanwhile, the mass of the solid hemisphere is equal to rho times the volume of the sphere divided by 2. So this becomes rho times 2/3 pi a cubed. So we now substitute this and this to our masses earlier. So this will now be equal to the sum of these two. So this is 1 all over. You will notice that common factors exists. So that's rho, pi, and a squared. This will be multiplied to 1/3 h plus 2/3 a times rho times 1/3 pi a squared h times h over 4 plus rho times 2/3 pi a cubed times negative 3/8 a. So here we can cancel rho, can also cancel pi, and we can also cancel a squared. So this becomes a. Doing the simple algebra, we are now left with the expression 3 over h plus 2a times h squared minus 3a squared divided by 12, which is further simplified to be ZCM equals 1/4 times h squared minus 3a squared divided by h plus 2a. So this is now the center mass of a uniform solid cone of base diameter 2a and height h and a solid hemisphere of radius a, wherein the two bases are touching. So that's it. This is the solution to problem 9.3 of Thornton and Marion, 5th edition. I hope you learned something today. Thank you for watching and I'll see you guys in the next video. Bye-bye.